You guys know that I bleed it nonstop. Every time I talk to anybody, I love fossil coloring. All right, so I start every one of my color presentations with this slide, which says there's no such thing as fossil color. So, as we know, fossil color preservation is really rare. It's fragile, it deteriorates over time. You either get it bleaching out to where you just have a white shell, or if it sits in the water and a lot of minerals and stuff get in there, you get a black shell. But you don't get the color patterns that were on it when it was alive. If you do get any color in a fossil, like that fossil wood back here on the table, it's usually because there's minerals that have gotten incorporated during the diagenetic process and they're just filled in and they make pretty colors that way. However, all of that changed for me in 2015 when I went to Topsail Beach and I started picking up all these fossils that had spectacular color patterns still on them that obviously looked like they were from the original color pattern of the animal when it was alive. So you have these beautiful sea urchins that have wraparound color patterns that go from the front side to the back sides. You've got, and they're purple or they're mauve. You have these sea urchin spines where the last third of the spine is chocolate brown, but the other 2/3 of the spine is clear. You have these barnacles that are red, and then you have hundreds and hundreds and hundreds of these ignodont oysters that have radioactivity. So I'm thinking to myself, wow, is this unusual? Is this an anomaly? Does this happen a lot? So I did some research online and come to find out in 1964, Stokes and Stifel wrote a paper about some other pycnodonts that had some banding on them. And then in 1988, in 2000, Bennington wrote about some other pycnodonts that had some striping on them. So I thought, hey, this is a real thing. It's not just me, and it's not just one site. There are other places that have fossils with color. I visited my friend George Phillips in Mississippi, and he had some in his collection, so I got to see them in person. And I was like, oh, really? So there are other factual fossils out there that have radio banding. It's a pycnodont, just like my ones from Coastal Beach. But these are all Cretaceous. Well, I happen to know where George got those at, Blue Springs, Mississippi. That's the site I know, so I thought, okay, I'm going to go to Blue Springs and find some myself. And finally I did. Now, it took a long time. You had to look through a lot of fossils, and there weren't very many there. But eventually I did find several myself that had radio banding, especially if you stick a black light on. A lot of these things look a lot better in a black light than they do in visible light, but most of these patterns are visible in natural light. Now, these all come from a sandy marl, Cocoon Creek Formation, and so it's almost sort of a kinship age with our PD formation, time frame wise. So then a couple of years after that, I went to a new place called Trick Pit with the Campbells. So the Campbells took me on a field trip. We'd gone to Old Dock, and then they took me to another spot that they knew that they had permission to get into. And we found these pycnodonts. And as soon as I saw one that had a little bit of faint banding on it, I go. And so I was running around picking up all of the oysters that I could. Now, these are very much less diagenetically altered, let's say, than the ones from Blue Springs. They're real chalky, they're quite unstable, but they do have the banding, and so yay. So I have another pycnodont. And these come from layered, laminated black shales with sand in different layers. And that's the Black Creek Formation. They're also. And then a couple of years after that, down at Holden Beach, picking up some stuff from Holden Beach, and lo and behold, there's another pycnodont that has radio banding on it. Now, that's it in visible light, and that's it in black light. And a couple trips later, I found one more, once again, very much more obvious in that black light. And these are coming from that interbedded sand and limestone that they dredged offshore and dumped up on the beach. So now I have another pycnodont that has radio banding. And then David Sanderson was kind enough to put a pycnodont in the auction last April, and I bought it, brought it home, stuck it under a black light, and there's more. I'm just like, yeah. And so I've got those specimens up there. And in fact, he brought me a couple more today, and guess what? Radio banding on them. So now I'm very, very excited. And then at Castle Hayne, from the Eocene, those were all Cretaceous. And then from Castle Hayne and the Eocene layer, I actually found a single little picnodon that had some radio banding. It's much more visible in the black light than it is in natural light, but you can see it in natural light. It's up here on the table. And it is also kind of not very diagenetically altered. It's kind of chalky, getting old. So just in picnodons, I've got 6 species from 4 different states and 8 different sites. Now that's incredible to think that things don't carry color anymore. So these 5 of the sites I actually collected myself, so I know they're real. 1 David got, 2 sites were in the literature. So of these 6 species, 4 are Cretaceous, 1's Oligocene, and 1's Eocene. So I've got the wide range of not only places, but time frames and whatever, all still showing fossils preserved with original color banding. So while I was at Blue Springs looking for those picnodons, one that I found actually had an exogyra stuck to it that had radial banding on the right valve. Now, so far, all of this color stuff's been on the left valve. But here's one that had a piece of it stuck on there with coloration on the right valve as well. So I'm going, well, maybe there's more that would have some on the left valve, because there's lots and lots of these big toenail oysters at Blue Springs. And I picked up a gazillion of them and exactly 1. Not a big on the side of it, but I did get 1 out of, like, I don't know, I've probably been there 15, 20 times. And I've got 1 that has that banding on the side. I did get a lot of pieces that show that there was banding going on. Just those happened to disintegrate, fall apart. But I did find that one that was banded. These are all coming from a sandy marl. So rare on these big toenail oysters at Blue Springs. However, if you go to Holden Beach, they're common in dirt. I mean, just about every 3rd exogyra you pick up at Holden Beach has been. So it's not like they're hard to find at all. So some of them have that same kind of like a single little thin band. Some of them have thick bands. Some of them are mostly dark with thin bands of light color. So it can range all kinds of different ways. And they're also banding on the right valves as well. So you've got banding on your left valve, banding on your right valve. This is normal light, this is black light, normal light, black light. Same specimen. So now I've got really common exogyras with radio banding. Go on. Stuff. There we go. So keeping in the toenail oyster kind of category, I have a friend, Donna Russell, who runs Geological Enterprises, which is like a wholesale fossil dealer place where she sells a lot of stuff to museums and schools and things like that, as well as other collectors. And she had a bunch of stuff in her school kind of collector stuff for outreach and found these Texagraphia that had some pretty faint, but still visible radio banding as well. So here's another Graphididae that has some banding. The Metagyra aretinus are common, so common all over Central Texas. And I collected those when I was a teenager growing up there. Never did look at them to see if they had any banding, because that wasn't in my brain at the time. However, I have now since gone back to some of the old sites and found some stuff. And sure, there are some that have banding. So these little Metagyras, so here's mine. So I got these from 2 different sites in Austin. There's banding on that one. You can see the banding on this one. And then George Phillips, again from Mississippi, had some in his collection that had wonderful banding. That were from Grayson, Texas. Then these were from Denton that I found a site in Denton right next to I-5. It's now been unfortunately covered over. It's a culvert. It's covered. It's really sad. Site's not there anymore. So, but they had really super obvious banding. And then Dawn also had these in her collection from Kingston, Oklahoma. So that's obvious that is the way that critter lived, and that's the patterns that it had on it when it was alive. So just for that one species, I have 5 different sites in 2 states that all show the same kind of radial banding. And so they're running up and down from Austin all the way up to Oklahoma. So from our extinct family Graphididae, so all of those are extinct. We never would have known what they look like, what kind of color pattern was on them. We've got 10 different species in 6 states and 13 sites. And I think that's absolutely incredible that those kinds of things can be preserved that long with a color pattern all over the place. So there were seven, I collected 7 of the sites personally, 9 of the species. Of the 10 total species, 8 were Cretaceous, 1 was Eocene, and 1 was Oligocene. So again, you have that same kind of stuff through time being consistent. So now we're moving on to the family Austria. So Rocky Point, Castle Hayne, North Carolina, PD formation. We're all familiar with that. Sure enough, occasionally you can get these guys with some banding too. It's not common, it's very rare. However, if you look really hard, and especially if you care about black light, that helps because it helps enhance the color. You get a little bit of banding here. So this is that specimen in regular light. Here it is in black light. You can see that banding popping out. And then here is the right valve. So this is the left valve, that's the right valve. And then over here, these are from, I'd say Rocky Point, but that's actually Cheshire Pit, which is now a lake. It's Cheshire Lake. But it was a fossil site for a while. And there it is on there. These are Fleming Austrias. That's it in regular light, and that's it in black light. That's a separate specimen. Also from the same site, this is that Cheshire Pit, which is now Cheshire Pond, or Cheshire Lake. They have some Graphioptera that also have some banding. It's fainter, it's not as obvious, and it's usually also only on that bottom part of the specimen. That's it in normal light, that's it in black light, normal light and black light. And it's an interbedded sand and limestone type of formation, PD. So we're moving up into the Paleocene, we get younger and younger. What do I have from there? So in the Paleocene, once again, I go up to my friend Donna Ross, and in her teacher collections, she had these beautiful little mini toenail oyster kind of things, looking like toenail oysters, but they weren't. I don't even gonna try to pronounce that. Odontographia, yeah. Okay. Odontographia. Once again, we got that radio banding this morning. And I have some of those up here on the table as well. And it was also in the literature from 1986. Someone had written about it back then. So it's not that it's unknown in the literature, it's just not very prominent. You don't find a lot of literature talking about this kind of banding going on. Moving up into the Eocene. So in Quitman, Mississippi, because this is a site that George Phillips took me to a long time ago. We went there because they had little sea urchins, but they're in really poor condition. It's a different kind of preservation. Like here, our sea urchins preserved very, very well. But in other conditions, the sea urchins, because they're calcitic, are like crappy preserved. But you get the arachnid stuff well preserved. So we were kind of going there for that. However, when I got to looking at the oysters, I went, hey, some of these oysters have really cool banding on them. Same as I've been finding other places. And so from Quitman, Mississippi, this is it in regular light, this is it in black light, regular light and black light. And then this is the left valve. Here's the right valve. And interestingly enough, the right valve also has some banding on it. You can see that light band down the center, light band down the center. Whereas on the left valve, it's kind of all over the place. So it's still radial banded, but it's different per valve. And then we went over to East Texas, where I collect a lot from the Weeches Formation. And once again, where you've got these Paleostrias, but of different species, 2 different species from East Texas, they again show the same kind of banding. So you have the same kind of sporadic banding on the left valve and the same kind of banding on the right valve, where they've got that clear stripe down the seam. And then this is that second species over here. It's more mock, but it's still, I still call it radio banding. And then you've got that banding on the valve as well. And that's from a green glauconitic clay. So we've got all these kinds of different formations that the stuff's coming out of. They're not coming out of the same kind of formation, they're the same kind of preservation. And there's my one little Castle Hayne guy again, because we're in the ACC. So he's so cool. I love him. And that was I found that on the last trip of the last time we got in before the hurricane came and everything got messed up. And I was like, never gonna find another one of those. All right, on to the Oligocene. So here's my topsil stuff again. This is what started my whole interest in this color kind of thing. Were these fossils from the Oligocene at Topsail Beach. So these are 30 million years old. And look at all that. And this is all in regular light. That's what first tripped me out to this, is because because of the unusual way that they were brought out of their matrix. So usually if you're a quarry, it's been kind of a manual process to crunch it out of whatever matrix it was in or whatever to get it out there for you. And if you find other things that are just naturally weathered out, that process takes a long time. And so by the time anything is naturally weathered out of whatever matrix it was in, I think color gets kind of faded or gone by the time you get that done. But on topsoil, because of that super unusual way that it happened, so they got dredged offshore, they got ground up by an auger, it got sucked up a pipe, and then it got sandblasted a mile to the beach, which blew away all the limestone matrix that was around all these things. They're denser, so they stayed sort of intact. And so it spits them out on the beach. I just got out of limestone and I haven't ever seen the sun. And so it's just such a fast weathering process that colors were still so incredibly intact and so vibrant. And so we've got this just awesome banding. And you can see it's like different bands on different stuff. Sometimes they were like super banded, sometimes they only had like one band. So it varied per animal. But you can see that they were definitely in place when this critter was alive. You can see how it gets offset when you get these little points of injury. So this is not mineral staining. It's very, very obvious that this was a pattern that was on this animal. So I don't have anything from the Miocene. Anybody out there? Miocene?
I gave you one. Austria, compressor Austria from.
Was that Miocene?
Yeah, that was Eastover.
No,
No, that was Eastover.
good, then I have one. Oh, I'm gonna add this for next time I show it. There'll be one from the Miocene. Moving on to the Pleistocene. So I had initially picked up something down in Florida when I was on a trip with Roger Portel. And just a piece, right? Just a little piece of something. And I went, I wonder if that really looked like it had radio band when it was alive. Well, Roger had a nice one in his collection, so he let me push it to show me what it looked like if it was an intact specimen. And sure enough, there's some nice radio band. And then this one came from Old Doc. So it's not the one I've ever found at Old Doc. It looks like that, but hey, I'll take it. Timothy even put that one in his book because he didn't have any other from Old Doc. This one just found in my stuff that I've been collecting. So I collected from, oh gosh, when did I start collecting Old Doc? 2012 maybe. And the stuff in my shed is from 2013 until now. So I'm just now processing over a decade's worth of stuff. I've got 64 bucks. 5 gallon bucks. My shed. And my husband says, what if you die? What am I gonna do? 64 bucks. So okay, so I've been
Sandbags.
so I've done 20. So and sure enough, one of the ones I pulled out, I was like, oh, this is really good bucket. So I gotta get through these buckets and find out what treasures are there that I haven't found. She must have loved it when I picked it up. But you actually didn't see this. It was all covered with the sandy stuff from the lots. And so it wasn't until I washed it off. I was sitting on my back porch out there with some water. I go, oh, wow. Put it over to the side. All right, so now I got another great example of an Austria. This one's also extinct though. Why are all my stuff that I have extinct? Okay, so I can't prove it. I can't say, go look at a modern ones. All right, so he's extinct, but yeah, there's McCall. And then this little crest Austria virginity. He may be alive.
They are.
It's still alive. So there we go. So I can match that one up with some monarch dollar. But that's also from Old Doc. And those were also all just found from my buckets of stuff that I'm going through. So I could find other stuff. Wait. So here's my take on it. So I've got 2 different families, Graphididae and Ostridae. Out of that, I have 20 different species that come from 8 different states and 22 different sites that all have fossil color preserved on them, visible color, radio banding on oysters. Wow. Take a look. That's a lot of oyster. That's a lot of color. that nobody had done, nobody's written this about this, nobody's said anything about this. I'm like, maybe they just didn't go to all this, maybe nobody's pulled this together yet. Right, so I'm weird because I've gone to all these different places, so maybe that would be a good thing, maybe we should pull it all together and talk about it. So these different things surprised me about this research that I did. First off was how many there were. Second to that was just the sheer geographical diversity. I mean, they're all over the map. You know, I didn't find any in California, but maybe I didn't look close enough. I have to go through my stuff in California. I got some places and stuff, maybe there are some. I better go through my stuff from there. And then the sheer number of different species and individual specimens. Because this is not, a lot of these aren't one-offs. Some of them are one-offs, but some of them I have like 1,000 of them that have color banding on, or I have several hundred of them that have color banding on. So it's not, once again, it's not like it's a one-off. So the cohesiveness of radio banding across all of them and through time. So whether it's right valve or left valve, you've got this radio banding going on these oysters, most of which are extinct. But through time, from the Cretaceous all the way up to modern, is that radio banding. The different depositional environments in which they were preserved, and their different stages of diagenetic alteration. So that I thought was important. So not only are these coming from a whole variety of different kinds of substrates, so they're not all in sand, and they're not all in clay, and they're not all in marl, they're in like everything. And yet they're still retaining the banding. So usually if you get something preserved like color or ligament or something like that, it's from a very specific kind of depositional process that was favorable to that happening. Well, these things are like all over the place from all kinds of different types of depositional environments. And yet they've all got color. So that's going on with these oysters. Actually, this helped them to retain the color better than anything else. I personally think it's the calcium, but that's me. And then that we're able to see what oysters from an extinct family look like. I mean, how cool is that? You never would have known what they look like in life if you were just looking at the gray rocks. So this is very, very cool, and I think it's amazing. So Dr. Jennifer Kedia is helping me to work on the stuff from tops. She started off with the echinoids, but is having a little bit of trouble with that. So I told her to switch to the oysters because there's a lot more of those. And the oyster color was obviously on that oyster when it was alive, whereas, well, so was the echinoid stuff. But the echinoid color that we saw on this first slide was in the skin of the echinoid. It wasn't on the text, the hard part. And it had to get transferred from the skin to the test after it died. And so you're getting a lot less of that color pigment showing up on that test. Whereas the oyster colors, okay, that critter laid that color down when he was alive. So there should be a lot easier way to find that out. And a lot of modern oysters have that kind of banding as well. So maybe we could use the pigments from that to look for the pigments in the fossil ones, considering that the echinoids are all extinct. So she's working with me on that. So I'm thinking to myself, well, maybe color preservation is not as rare as we thought it was. Maybe we just haven't been looking. Maybe we've been passing off some stuff that was color as, oh yeah, that's just a mineral stain, which I would have done for some of the ones I had if you hadn't found 100 of them. And I went, okay, well, that's a little weird. It can't be 100 of them being stained the same way. So there must be something else going on here. So maybe that we're overlooking them, or possibly, as I said, it's an issue with how these things are eroding out of the matrix, right? So tops, I'm getting color from everything simply because it got out of its matrix in such an unusual way. Most of these other places are not. They're quarries, they're road cuts, they're other kinds of things like that. So oyster coloration just must be super stable and not deteriorate over time. So another quick view of them, because everybody likes pictures of things. Well, they don't, but they like pictures of the color. And so they're a under-loved thing, but I love them now because, hey, that's really cool. Look at all that. So that's my presentation. Who's got questions?
You went in 2015 to originally discover this at Olsen Beach.
Hold on, no, Pops.
Okay, I remember when you did the presentation, but have you been back 10 years later and seeing any fading in?
At Topsail Beach, the material stayed around for about 3.5 to 4 years. And then it was all washed back into the ocean because it's an erosional beach. So they dumped up X number of feet of sand and it's gone. So there is no more stuff at Topsail Beach. But what I did do was take some of my specimens. I did a bleaching experiment where I put them outside in the sun, and I put like black tape across part of it. Did it to the echinoids, did it to the picnodons, the oysters. And it takes a long time, but it does bleach. They will bleach out. So it is obviously color, because it will bleach out to where you can't see it, but you can't see it with black light still. And then I don't know if it ever eventually bleached. I gave up on it after a year. I gave up and didn't bleach it anymore. But it took almost a year to bleach the visible color out of the oysters. But they did.
That's my second question is, going through your 60 buckets of stuff that you have you gotten good at seeing striations so you're not having to do every single thing under a black light just to see it?
Way better. Way better. Yes, I mean, but now we've got the whole black light thing going on, right? Where you saw in the last couple of meetings, I brought a bunch of the black light material where you could see patterns with the black light that you couldn't see with visible eyes, right? So now I've sort of gotten to know which ones are gonna be or could possibly have that color, black light. And so I set them and I check them all out. And I've also learned a way to make my fossils black. You want to know it?
Yeah.
All right, so if you take your old dock stuff that doesn't have any black light, and shine your black outline and no color pattern, stick them outside in the sun and leave them for a couple months. And they will, about 90% of them are all complex color pattern. Actually, in the summer, it took 2 months in the summer to do most of them. The bivalves do faster than the gastropods do. Gastropods are slower, but you can cook your own color into your black light color into your custom, which is cool. So that's what I'm doing now. You should see my house. I've got the big screen thing set up all around my house. James will tell you, right? I've got this big screen thing, and we go out and I say, okay, it's time to take a picture again because we're trying to document how long it takes for each thing. And so now you turn the black light on, and all the bugs come. So all the bugs are there while we're trying to take pictures of this stuff to show how they're doing it. What are they called? The cockle shells. Okay, they'll start showing a color pattern in like a week. I mean, they're the fastest. The color pattern shows up in about a week. Glycymeris takes about a month. Some of the other things take longer, and the gastropods take a long time. But they do eventually start showing a color pattern.
Do you have any idea what the chemistry is of why the sun is bringing out?
Absolutely not a clue. I talked about it with Sean, and he goes, that shouldn't work. I said, I know, but it does. That's a bad number. So yeah, that's something we need to study to figure out why it works. Because you really have no color visible, no color black. Leave it out in the sun, and all of a sudden this pattern starts developing. You're like, how is that possible?
Maybe the non-color parts are fading.
But the parts that are color actually show up in like pinks and bright yellows, and so it's some sort of chemical that's reacting that's showing it.
Just to add to the Topsail Beach thing, they once in a blue moon still find that stuff, and I did see one that had some nice color. That was probably about a year ago. And actually, someone gave me one that has a little bit, but couple questions. So have you ever tried to get one of the how do you say Graphiidae, the modern one, and look at them?
No, haven't gotten any.
There aren't many, but there are some. So,
Seriously?
yeah. So there's a couple I think still around.
And as far as like when you first asked about Topsail Beach, about the stuff is fading from Topsail Beach, because Topsail is an erosional beach, every tide strips off what's there, and so you're looking at progressively lower and lower layers. So whatever you're looking at hasn't. And so that's what you're, and same thing with Holden Beach now. So it's just going down. You're seeing the sand's washing away and leaving where.
Yeah, that was my other question. Do you think Holden's, because it was all in the sandstone, kind of like Topsail's in the limestone? You think that may have a little bit?
Similar, yeah. I think so. And that's why there's so many of those toenail oysters. There's divers that have the banding because they got out of there in such an unusual manner.
Right.
So,
Nice.
yes,
You go ahead.
okay. Quite nice.
All right. Yeah, I really like the experimental approach of looking at basically putting them out in the sun and seeing if they fade.
Yeah,
But yeah, after a year, kind of get bored with that. So have you looked at any archaeological site oysters? Because middens are full of them. Some of those things, have been in the sun for like thousands of years. And see if there's any color left on any of the oysters, and two, if it's preferential to oysters. Other bivalves.
that's a good idea. To take that research on the lawn. It's a good idea. Try it.
Along the same lines of that, if using UV light brings out some of these colors, and if you take specimens that don't have color and leave them out in the sun, question in my mind is it the UV from the sun that's activating these colors, and could you use specimens left out in the sun under different filters to see what frequency of light is activating these colors?
It's entirely possible. So, because everything I picked up from, say, like Tossel, right? So I got most of the oysters do have visible banding. Some of them don't, but those oysters may never have banding to begin with because it can range anywhere from no bands to almost completely banding. So I never thought to put them out in the sun to see if they would develop any kind of black lighting. I've never done that. I could try that and see what happened. But then I get what you're saying is that see my thoughts were when I took the oysters that had the visible banding and I left them out in the sun, the visible banding went away over time. But they would still show up in black. And I haven't left anything out long enough to see if eventually that goes away. You know what I'm saying? So I know that the sunlight brings out the black light patterns in the old dark stuff, but I haven't left it out long enough. Once it shows a pattern, I take it back inside and I go, so maybe I should leave some of those because but something that I have a lot of, maybe I should leave it out continuously to see if it will eventually just bleach that out and just make it, all yellow like calcite, and then the pattern goes away. I should probably do that. See if I can actually make the pattern vanish. Gone, there, and gone. And see if that's a thing, or whether they continue to keep that pattern. And also, and I noticed that I put some of my stuff that had black light patterns, I've had it up and inside now for like a year. And some of the stuff that's been in the buckets for a decade, when I take them out of the bucket and hit them with the black light, the pattern still shows up. So apparently once the pattern's there, even if you take the light away, it doesn't stop that reaction from happening. Because I pulled stuff out of 10-year-old buckets and all of a sudden it goes fluorescent. So it didn't mean.
I mean, the other thing you could do is, if it is the UV from the sun kind of activating some of these latent color patterns in there, is send it into laboratory conditions where you bombard it with very intense UV radiation over short periods of time. So if it's taking months, absorbing sunlight, I mean, can you shoot it in basically a black box in a lab and make it glow with like a few minutes of very concentrated UV? Well, I mean, we don't have that here, but I'm just saying there are these places do exist. No.
To donate to anybody that's collected for. Okay.
I had another, on that topic, because going in the UV, do you think there is a chemical component to it as well? Because if you notice, a lot of the old dock stuff's kind of lighter than the fountain stuff that we've seen. And then the Florida stuff down in the Pleistocene there is just crazy bright, like insanely so. Do you think maybe there's like some kind of preservation condition that also aids in that?
I know fictional conditions do contribute to it, and I don't know how to explain that. Intrinsically know that happens. I don't know that it makes it any more likely. So we have the black light stuff showing up in the fountain stuff, which is 4 million years old, and then like Tony says, they're different color. They're kind of grayer. So I would say they have more gray tone.
Yeah, maybe that's brighter.
Yeah, the stuff from Topsail, the stuff from Old Dock has kind of a warmer tone to it, sandier tone to it or whatever, whereas the stuff from Florida is like ice white.
Yeah, and if you
From
get,
SMR, it's a different color. Like you can show me a fossil from SMR, from Old Dock, and from Fountain. And if it was the same fossil, I could tell you which site it came from just by looking at it. Because you can see the difference.
it's just like hitting the floor ones. It's like a neon sign. Once you hit it with the UV, it's bright.
Yeah, stuff that Trish had, that she had in the auction that I took home, and they're like electric blue.
Yeah, you gotta like, oh, man.
They blind you.
So,
Trish?
You had mentioned that there wasn't as much color or banding on the right valve, but more on the left.
Yes.
Is usually the right valve, the one that's against the substrate, against the sand, or against the matrix.
I think it's the left valve, isn't it? I think the right valve is the small one, and it's the one that opens up, and so you have to have the left valve to be the one that's attached, if it's attached. I don't know.
Okay.
I did notice, and in the literature, they only talked about the left valve being banded. Of the three whole papers that I ever found anything on, two of them talked about just the left valve being banded. I think one of them didn't talk about which valve was banded, but it did show both valves being banded, but that was the Australian, not the graphitted, not the family graphitted. So in the family graphitted, which is the Pictodons, they only talked about the left valve being banded, but I did find somewhere the right valve was. They just probably didn't have enough samples. It wasn't that common.
What is a lefty? I'm liking that.
It's not a left valve. My sister would love it too, and my son are all. Anything else? So when I get to give a talk again, so I'm working on the black light color for my talk at GSA next month. So once I get that all done and I have another presentation, hopefully I'll get to come back and talk to you guys about the black light colors, because that's really cool. So I'm comparing the Old Dock stuff to the Fountain stuff, and then looking at the broader implications of what that says, because there's some things that were at Fountain, they were at Old Dock, and they're mono, right? And so at Fountain, there's one color pattern. At Old Dock, there's three color patterns, one of which is the original one from Fountain. There's a hybrid pattern, and then there's a modern pattern, and then today's just the modern pattern. So you can watch this color pattern morph through time, which is really so cool. And I'm like, so does that mean that this one is the same as that one? Because it's a totally different color pattern now, and yet they've got the same name. And then I'll find things that have the same color pattern here and the same color pattern now, but now the name's different. Well, why? Because nobody had a pattern to look at before, so they didn't know they looked the same. So somehow or other they changed the name for the modern one, and I'm like, oh, it's exactly the same as the 2 million year old Old Dock. So what's the deal? So it could be an interesting tool to help people start looking back at how things have been classified and identified. If you have this new tool, this color pattern, to help you look at things. So I look forward to being able to share that with you after we get more of that.
Thanks.